So this one is fine, sir.
Uh, Sahil sir, can
Okay,
you,
Bhavna, you may start. We are live now.
Sahil sir, just a second.
Yes. Mhm.
Sir, can you share the link to the Telegram group so that
Sure, sure, sure. I'll send you, Ravinder, and you please post it on Telegram group. Okay.
yes, sir.
A very warm morning and happy Independence Day to everyone watching us. We would like to welcome Professor C.P Gupta, the Honorable Resource Person for the day, my colleagues, and all the participants to day 4 of this Faculty Development Program. As you are aware, today's session will be conducted by Professor C.P Gupta sir on descriptive statistics and sampling. Professor Gupta is presently Professor in Department of Financial Studies, South Campus, University of Delhi. He is MCom, MPhil, PhD from Department of Commerce, Delhi School of Economics. He has a teaching and research experience of more than 30 years. His areas of research, teaching, and consultancy include investment decisions, risk analysis, project appraisal, security analysis, fuzzy decision making, and financial modeling. He's a life member of Operational Research Society of India, Society for Capital Markets Research and Development, and the Indian Financial Management Association. He has contributed a number of research articles in various Indian and international journals and has a few research-based books to his credit. He guided a number of research students. He is involved actively in the training program of NTPC, ONGC, ABB, Sapient, EXL, EMB, Daksh, and many others. He was a member of expert group appointed by the Government of India to review cost accounting records rules and existing cost edit report rules. He is area editor of the Journal of Indian Business Research. So, we would like to invite Professor C.P. Gupta to elucidate on descriptive statistics and sampling. Before we begin, we would like to inform two important things. Number one, please find the data set and material useful for today's session on the Telegram group and the online platform. And secondly, all the participants can post their queries while the session is going on the discussion group. Thank you. Sir, you may begin.
Okay. Thank you, Bhavna. Just one question. Are
Yes,
you able to see my PPT?
yes, sir, we are. So right now it's the mail that we are able to see.
I think my this is freezed. So let me share it again.
Yes, sir, it's visible now.
Uh, what about this?
Sorry, sir.
Uh, what I'm saying is when it asks me to share,
Yes, sir.
it's asking me to share a particular thing, but I want to share the full screen.
Sir,
I do it again. Share screen.
Sahil sir, can you help
I want
sir
to
with this?
share because I will be switching from one screen to the other screen. So if I select a particular screen now,
right.
then I cannot share the other screen.
Oh, no, so I guess you will be able to share it as you. So whatever
So
is visible on the window.
I show you. This is my screen I'm sharing with you, right?
Yes,
Okay. I want to go to our study. Now you are not able to see it.
yes, sir. So there are two options. One is there are two options while you are trying to share the screen.
Okay. Should I do it again?
Yes, sir.
Advance. You mean to say advance?
Yes, sir.
Uh, Sir, I hope you have shared your screen. If you share a particular website or browser, then you may face difficulty. So
I'm not getting the
there is an
option.
option share screen. So you please click on share screen.
Share screen. I have clicked that.
So,
What I'm getting is whiteboard, R Studio, descriptive, that PowerPoint and other folders which are open, and is asking me to share, to click only one of them.
sir, please click on the share screen once more.
Right. Uh, if you give me a phone number, I can show the live video of this screenshot.
Sir, uh, wait a
It's
minute, sir.
asking me share the computer sound. Because I will be working on PPT, Excel, R Studio, all these things, all these three screens I will be working. But it's not allowing me to do that.
Sir, exactly what problem you are facing? Please tell me.
When I go to share screen,
Yes.
it show me the different screens like whiteboard, R Studio.
Yes. So there is a single. Is there any screen option? Can you see screen option?
No.
Okay, so you do one thing, sir. You please, take yourself out and then again come to the meeting.
Okay.
Hello,
Yes, Ravinder, sir is about to come.
sir. I think there's a problem in my computer also, that there are only
Okay, let me
four or
check. Hmm.
4 or 5 windows in this. I'm sharing you the screen photo of it.
साहिल एक साथ 3 स्क्रीन शेयर हो जाएंगी?
या नहीं, एक बार में एक की स्क्रीन ऐसे
एक ही
कर
होगी ना?
सकते हैं। हाँ हाँ।
Sir, I'm sending you the photo of it. I think
So
Sahil sir,
please try now.
can you
I've
make
signed out, I've again joined.
Okay, can you please share a screen now? Vipin, can you please see?
Now
We
when
can.
I go to R Studio, for example, then it's not coming.
Vipin, can you please help CP sir?
We can see sir screen now, right?
We can see sir's screen, but
What you are
actually,
seeing in the screen, the PPT, no?
So there is a screen option in your when you click on screen share, then you can find a screen option.
No, I'm not getting that option. That's the problem.
Sahil sir, could you make him a host so that
yes, I'll just try to do that.
yeah.
Sir, please check now. Can you see?
Okay. No. It says selected application you want to share. It is
Sir,
asking
in
share
that
a
case,
particular application.
in this case, sir, you have to switch. Like for example, you want to show R screen, then in that case, stop and then again go to the R screen. I don't know why it's not working, but
But
this is the
every time it works,
You have to do multiple times, sir. Actually, you just share PPT and then close it and then share our screen. We are sorry, but I don't know why it is happening.
but that's it. You that will waste a lot of time. I don't know.
But sir, for now, actually, we have to do like this only.
But is it happening first time or it is happening other time
No,
also?
it's happening first time, sir. Sometime it happens, but when you log out yourself and then again log in, then it actually resolved.
Hello. So what I do is I just share the PPT, right?
Yes, sir.
Okay. And now PPT is coming up. Okay, so should I start? Hello?
Yes, sir. You may
Yes,
start.
sir.
Okay, okay, okay. So friends, good morning, and we are sorry that there was some problem to start with. Hopefully we will have a smooth session. So welcome to the session on descriptive statistics and sampling. So let's start with the thought that says, you know, just minimize it. Okay. It says, if you know nothing about statistics, then you are missing excitement of the life. Statistics is very, very important, and it is expected that we must understand statistics, we must use statistics, and we must work with statistics. Statistics is a journey from data to wisdom. Statistics provide us data, and through that particular data, we try to get some wisdom out of it, some inferences out of it, some conclusions out of it. So we have to learn statistics to build our own capability to derive meaningful results from our data. And that's the focus of this particular session. We have to develop our capabilities to derive meaningful results from the data which we want to process and which we want to analyze. But before we start with today's agenda, I have a question for you. As a user of data, what is the first thing that comes to your mind? Just imagine. The moment you have data in your hand, what is the first thing you have to do with that particular data? And you will find you have to describe the data by using tables and charts. As a user of data, that is the very first thing you must do. Make the necessary tables, make the necessary graph, and it has two reasons for it. Reason number one, it summarizes your data. Reason number two, it helps you in understanding the behavior of the underlying data which you are going to study. And therefore, whenever you start with your data, the very first thing you have to do is you have to describe your data by making use of tables and charts. Assume that we are studying the behavior of consumers in shopping malls and we have collected this particular data. So the distance traveled by the consumer, less than 5 kilometers, 5 to 10 kilometers, 10 to 15 kilometers, the number of children the consumers have in a family and the frequency of buying. So huge data have been summarized into a particular table, okay? And it can be further summarized, in a very compact table like this. So how many families have one child and traveling 5 to 10 kilometers? 14 families. There are 10 families which are having two children and traveling 10 to 15 kilometers. So now you can see the whole picture is before you, and you can easily understand your data, and you can also interpret that particular data. So that's the beauty of having a table and doing the summarization of the data for us. You can make a graph like this, one child, and you have difference, distances traveled by the consumer and the frequencies they have. All those things, you can show it on a graph. And as a user or as a reader of the graph, you can get the complete picture of the data before you. And that's the idea of preparing charts and graphs. Helps you in communication, provides you the overall view. You can also understand the behavior of the data. And if there is an outlier, that can also be identified. So if we interpret the data something like this, how many families are having a number of children, 1, 2, 3, and traveling different kilometers. Say, for example, more than 15 kilometers traveled by consumers. And they have one child, two child, three child. And you'll find there is not much difference in the data. Okay. On the other end, if you see, less than 5 kilometers, it's 15 here, 15 here, but 28 here. That clearly shows that families with the larger children, larger number of children, will like to go to the malls which are within the radius of 5 kilometers. And that's the message you can easily get from the graph. Okay. Let's take an example and see how can we do it in the Excel. So if you have data with you, please open up that file. And the name of the file is birth data. And the utility of the Excel which we are using is a pivot table. Pivot table help us in summarizing the data. You can make the tables the way you want to have them. You can also classify, and you can also have the charts of those particular data. Okay, so if you have the data with us, with you, please open up and try to work along with me, and you can see the birth rate between 10 to 15. There are 4 states, and you can also make the graph of it like this. And if you want the death rate, you can drop the death rate here. If any one of you facing some problem, please let me know about that. I will repeat the whole process again. Now, you go to insert. In that insert, you will find the option of pivot table. click on that pivot table and select the data and then click. And once you click it, then you will get this kind of a window. And from this window, you can decide what is to be put in the row, what is to be put in the column, and what you would like to see in the body that you can show. Okay. If any one of you facing some problem, please let me know about that. Okay. So please go to insert, and in that insert the pivot table. And in that pivot table, the moment you click on it, it will be asking for the data. You select the necessary data, and then you just say OK. So once you say OK, you get a screen, something like this. Right. So you have a screen here, you have the here, whatever you want to show in the rows or columns, you put it. And I'm putting the count of states in the values. And to have a uh, class interval, then you click on this table, right click on it, and you will get the option of group. And then you give the range, the starting and the ending, and the class interval, and you will get the table. Uh, we can get a pivot table in Excel by clicking on insert, and the moment you click on insert, you will get the option of pivot table. I show you how we can do that. I'm just opening up this file birth rate data. So I have to log out, then share screen, Excel, share. And now you can see it. So go to insert, and the moment you go to insert, you will find the option of pivot table. Go to pivot table, click on it, select the data, and then you say OK. Right? And that's how we get the pivot table. And once you are seeing this screen, and if you want the birth rate in the row, click on it. Sorry. If I want birth rate in the row, put it there. States in the value, put it there. And right click on it you'll get the option of group. Starting, let's take 10, ending 30. And if I take a class interval of 5, then you say, okay. And that's how we get the class interval. And if you want to make a graph of it, you can make a graph of it. For that, what you do is you go to home and go to uh, analyze, and in that analyze, you will get the option of pivot chart. Click on it and you get the chart. Is that clear? Any doubt, any question about it? And like this, you can do a lot of things with pivot table. And pivot table is a wonderful tool in Excel. And this utility can help you in making tables, cross tabulation, graphs, averages, standard deviations, everything you can do with this particular pivot table. Anybody else? I hope, Mr. Ravinder, you are able to understand what we are talking about.
Yes, sir. Yes,
Okay,
screen.
right. So I have to share my screen, PPT. Okay. So by making use of pivot table utility of the Excel, we can make tables the way we want and we can make their graph as well. So friends, devote some time, please work on the Excel and work on the pivot table for your data. And I tell you, you will find a lot of advantages of the pivot table. Even if you do not know any programming, doesn't matter. Just pick and drop. That's what you can do in pivot table. Okay, so now let's discuss two important graphs that shows the behavior of the data. And I do not know whether you are already aware of it or not, but you can understand that. Okay, but that's very important. Uh, these two graphs are very important graphs to understand the behavior of the data, like whether your data is normally distributed or not, whether your data is skewed, what is the average, what is the dispersion, all that information you can get by making use of these graphs. So let's go ahead and see what are these two graphs we are talking about. We can make use of histogram, and that too with normal curve. And another very powerful graph is called a box plot. So before we go to descriptive statistics, let's devote some time in understanding the histogram and box plot. And then we would like to uh, prepare this chart for our data by making use of R. So that's how the graph looks like. This is the normal curve which is imposed on it. Okay, you can see there is some kind of a skewness, right? Distribution doesn't looks to be a normal distribution. And please remember, histogram cannot be made for nominal data and ordinal data. You can't make the histogram for such data. Histogram can be prepared only for scale data. Okay, so if you have the scale level data, please make histogram to get the behavior, to get the view or understanding about behavior of the data, especially whether your data is normally distributed or not normally distributed. Then we have another important graph which is called a box plot. That's how it looks like. You can also have a vertical version of the same. It's your choice. You can have it horizontally. You can also have vertically. These are called the whiskers. This is my quartile 1, which is called the lower quartile. This is my quartile 3, okay, which is called the upper quartile. This is my quartile 2, which is called median. Okay, so this graph straight away will give you an idea how many observations are below 25%, how many observations are above 25%, and where is your median, the average. Look at, and that's the maximum and minimum. Okay, that's how the box plot looks like. And this values which we get, these are calculated as the quartile 1 minus 1.5 interquartile range. An interquartile range is defined as Q3 minus Q1. Interquartile range is defined as Q3 minus Q1. And this minimum point which we get is calculated as Q1 minus 1.5 interquartile range. And this maximum we get as Q3 plus 1.5 interquartile range. Okay. Box plot also help us in understanding the outliers like this. It's an outlier. Okay. It's not falling in the line of the most of the majorities, and it's an outlier. And as a researcher, you have to take a call. What should we do about these outliers? Okay. Box plot also help us in identifying differences in different variables. Like here, see, you can compare their averages, and you can also compare their variations. And that's how the box plot helps you in this particular regard. Okay. Right. Let me finish discussion on the box plot. Then we will go to explain how can we make a graph by using pivot table, and we will also prepare the histogram and box plot by using the R. Okay. So let's go to R and draw the histogram and box plot. I've also sent you the commands for drawing it, or you can follow us and understand the graph. But before that, let me go to Excel and show you how can we make a right. So I delete this graph again. And so to make this graph, you have to click anywhere in the table. Okay, suppose I have clicked here, and then you go to pivot table design, click on it, and in that you will find the option of pivot chart, pivot table analyze and pivot chart. The moment you click on it, you will find a chart is appearing. And now you can have a line chart, you can have a pie chart, Suppose I want to have a pie chart, so click on the pie chart and you get the pie chart. So that's how we can make the charts by making use of pivot table. Okay, and this is automatic. This is having automatic update. So for example, if I put death rate here in the column, okay, and I group it, sorry, if I group it, minimum is say 0, maximum is say 10, and class interval 2, then you get this graph. But the pie chart is only for one, for one set of data. But if you want graph for both, you have to change the graph type. Suppose I go for column charts, and now you can see it. You have the death rate as well as you can also have sorry, right. So we can have a death rate, and on the x-axis you'll find we have a birth rate. So that's how you can make the graph in Excel by making use of pivot table. So friends, let's go to R now. Please open up your R. And you can download the data by making use of file and then import data set from Excel. You go to file and just put it here, file, import data set, and then you select Excel. And then you select the file where you have stored that particular file, and you will see the result. Uh, Mr. Ravinder is asking me a question about normalization of the data. In Excel, you cannot do the normalization. For normalization, you have to use some other software. Maybe you can make a small program in R for normalization purposes, or you can make use of it in SPSS, and there you can get the normalized value. But Excel will not help you in getting the normalized value. However, you can put the formulas of normalization in Excel, and thereby you can do that. Okay, right. So let's go to our sorry, and data file. I hope you are able to get. Then we are using commands. This is the library you have to use for getting the Excel file read, and that's how the command for reading the Excel file. And then I can attach the marks. If if you want, you can see the structure of the marks. Okay, so I hope that you understand these basic commands. So let me run them. So I run these commands together. The library redirects because it is to be downloaded, marks to be read, and marks I'm attaching with to use the variable names comfortably and the structure of the marks. Oh, I'm sorry, my file is not in this particular folder, so I have to import my file. Excel, browse, and the birth rate data, open. And okay, so then you say import, and you will find the data is being imported, and that's the view of the data which we have. So we have different states, and we have the birth rate, death rate, and infant mortality rate of these states. You'll see here. Okay. So let me go to this, and here before I use it, let me add one command here because the files have been imported by using birth rate. So what I do is I say marks equal to birth rate data so that I have a smaller name. Then I attach it, structure it, that the structure you will find. So we have variables which are birth rate, death rates, and infant mortality rate. Okay, so that's the structure of the data which we have. And let's see how do we make the histogram by making use of it. Command is very simple. You have to use the command hist. Okay, so this command is for setting the background and the graph window. Okay, so C12 means in the graph window, I would like to have one row and two columns. Okay, and the background I'm going to get with the color, BG is for the background color, which is floral white. Okay, so I run these commands. And then you will find out. So we are working with the birth rate data. Sorry. Then I define data is equal to marks. And you know why I'm doing all these things? Because in my following commands, I've used data name for the variable. And that's why I have to do this. Then structure, summary, and attachment. The structure we have already seen. So let's go to the summary. And in summary, you will find you get the minimum, you get the minimum value, first quartile, median, mean, third quartile, and maximum. So summary command will give you information about the minimum value and the maximum value, first quartile, second quartile, that's the median, and the average, the mean, and the third quartile. So if you're looking at that particular set of information, you can make use of summary command. Okay. Then let's go to attach. And then I'm making use of the histogram. And you see, you get the histogram here. But this histogram is without normal curve. So I want a normal curve in this graph. And let's see, how do we draw the normal curve in this particular histogram? Okay. To define a normal curve, you have to have the mean and standard deviation of the data. So we are calculating mean by using the mean command and storing it in M. The standard deviation is nothing but the square root of the variance of the birth rate. Okay, so and then we are drawing the curve, which is d norm x by default, mean M, standard deviation STD. And you will find that you get a histogram with a normal curve. And very high peak that shows data is not normal data. So friends, that's how you can make a histogram in R. Command is very simple, hist and the variable name. Okay, but if you want to add into it a normal curve, then you have to calculate the mean of it, the standard deviation of it, then use a command curve d norm x, that is the for x variable we are calculating the normal values whose mean is m, standard deviation is STD. And this m is coming from here. And then other parts of this command just to add, you know, just to do the beautification of the histogram. Okay, so friends, let me repeat the same commands again so that you can understand it properly. Now we get third graph. So that's how you can make graphs. And if I similarly, you will find we have the commands for death rates. We have the commands for infant mortality. And one thing you have noticed that here we are able to make three graphs on the one screen. And that is possible because of that bar command with C1, 3. One row and three columns for three graphs. That's how we use that particular command. So friends, I'm going to select these all the threes together and run these commands in one go. And you will find we get three different histograms. This is for the birth rate, and this is for the death rate, and that's for the infant mortality rate. Okay, so I hope you are able to see these graphs by making use of this. Okay, and let's see how do we make the box plot for the same data. The command for the box plot is very simple, and it says box plot. Okay, so box plot and the variable for which you want to draw the graph. I want to draw the graph for birth rate, death rate, infant mortality rate in the same graph. Okay, so simple, very simple command, box plot, and write the name of the variable. So box plot and the name of the variable. That's the command which we use. Okay, let's run it and see how do we get this. And now you can see we are getting three commands. Sorry, we are getting three boxes, and one box is giving me about the birth rate. This is for death rate, and that's for infant mortality rate. That's the average. The death rate, average rate is lower. Infant mortality rate is very, very high. Okay, and this is the minimum and the maximum, and that's how you get an idea about this. So you can make your box plot by making use of R, and you can understand this. Okay, any question if you have? Before I go further, let me take to discuss something. Let's try to understand what we have. This is the maximum, this is the minimum, this is the Q1, this is Q3, this is the average, median. Suppose I have another one, which is something like this. Okay, Q3, Q1, and this is the median. Okay. Friends, I'm sorry I have to share my screen again. Friends, are you able to see this graph? So we have a median here, Q1, Q3, and this one. If you see here, the median is approximately in the mid. That gives an idea that the distribution may be normal distribution because 50% above and 50% below, they're almost same, identical. Okay, but if I compare it with this graph, then you will find 50% here and 50% is here. That means distribution is not a normal distribution. It must be a skewed distribution. And that's how we understand and appreciate the box plot. Okay. If any one of you have any questions, you're most welcome for it. So friends, I hope you are able to understand histogram. So make HIT, the variable name, box plot, the variable name. Okay, same exercise you can repeat with the other file, which is having data related to maths, marks, and the uh, marks in computer science. I do it hurriedly. And so let me import again, file, import data sets from Excel, and I browse for the file. File is marks in math and computer science, open up. Then I say import. Then you say import. And that's how you will see you are getting the marks in maths and in computer science. And command for this is view, and in view the V is capital V, and then you write mark, the variable name X, and you can see the graph. Okay. And the R has read the variable data and store in a variable which is marks in maths and computer science. So just say it equal to this, then attach and see the structure of it. And you'll find in this structure, we have two variables, marks in maths and marks in computer science. And let's quickly make the histogram and box plot for these marks. So first, let's make the histogram for marks in computer science and marks in maths with normal data. And you will find we get the graphs. And you can very well see the distribution is not a normal distribution, skewed distribution. Okay. And how do we make the box plot for the same? So the command is box plot, marks in computer science and marks in maths. And in this graph, you can very well see we have some outliers. That means some students are scoring marks 99, but majority of the students are getting marks in this range. And there is an outlier on the lower side as well in the marks in the marks in the maths. So friends, I hope you are able to understand histogram and box plot by making use of R. Having discussed this, let's go to the descriptive statistics. So once we make the tables and the graph, then second step is we have to understand the behavior of the data using the basic statistics. So when we talk about basic statistics, we calculate 4 measures. Measures of central tendency, measures of dispersion, measures of symmetry, and measures of pickedness. In measures of central tendency, primarily we talk about mean, median, and mode. In measures of dispersion, we can talk about range, standard deviation of the variance. You can also calculate interquartile range. That's a Q3 minus Q1. And as a measure of symmetry, we calculate skewness and kurtosis. Okay, kurtosis is of 3 types. Assuming this is my normal distribution, then this will be your leptokurtic, and so I have to put the charger on here, and if I draw one more curve here, so this is leptokurtic. The normal one is called the mesokurtic, and the lower one is called a platypus. So how many observations are in the center? That is what is being reflected by the measure of kurtosis. Okay. So we can calculate these measures by making use of Excel and R. So let's first see how can we calculate, do it in Excel, and then we shall move to R. We can get all these basic statistics in Excel, and the command is go to data, data analysis utility. In that data analysis utility, you will find the option of descriptive statistics. And that's how you can get it. If you do not see this utility in your Excel, you can add it into Excel. And for that, let me share with you one video in this regard. And you have the data here. Go to data. In that data, you will find data analysis here. If you are able to see it, if you don't see this data analysis here, then what you can do is you go to File. In that, you see the option. Click on Add-ins. And then you go to Excel add-ins at the bottom. Click on the options, and after that it will take 2 seconds to add in, and that's how you will get the final data analysis. So I hope you are able to get that data analysis utility. Mr. Ravinder, participants are asking about the utility of the command, because in R is command driven. So we have to, if we are working with the R, then we must learn the commands of the R. So I think that's the utility of it. Okay, another question is the commands which we are using for importing it, that's for Excel. Okay, so CSV, for CSV, we have a separate command. Okay, so is that clear? For importing the CSV file, we have a different set of commands, but for importing Excel, you can directly import, or otherwise you can write the command for importing the Excel file. So friends, I hope you are able to get an idea how to add in the data analysis utility. And let's see, how do we get the basic statistics from data analysis utility? So go to data, pick up data analysis. And in that data analysis, click on descriptive. Then give the input range, group by columns, click on summary statistics, and then you say okay. And you'll find you get the statistics. And now let's see what this statistics tell us and how do we read this particular output. So let me put it in a proper format. And then we will see how do we get the extension. Ravinder, the answer related to the graphics is not the agenda for the session. So I'm sorry, I may not be able to take up those queries right now, because if I enter into plotting of different kinds of graphs, then we may not be able to cover the agenda of the session. So please say to the participants, we are sorry, we may not be able to handle that stacked bar charts in in R. But however, if they want to make a stacked bar chart in Excel, they can do it comfortably. Okay, so let's look at this. The mean marks in maths is 45.025. Computer science marks are lower. That means people are scoring more marks in maths as compared to computer science on an average. Okay, median is 42. 50% of these students got 52 and less, and 50% people are getting the marks 42 and more. Here, 35. 50% is scored by larger number of students, marks in maths, 40 in computer science. Range is 79, that the difference between maximum and minimum. And maximum is 99 here, maximum is 99 here. 40 students data we have, and that the sum of the total. Curtices is 5.78. That high peak, and that we have already seen when we draw the histogram, and skewness is positive, like this. That's the kind of the data we have for marks in maths and the computer science. So that's how you can interpret your data. Let's go to R and learn how to get the basic descriptive statistics. Okay, to work with to calculate skewness and curtices, you have to install a package called moments. And the command is install.packages moments. And this command will work when you are connected with internet. So once that package is installed, you call that library moments. Summary command, if you remember, gives you the minimum value, maximum value, quartile 1, quartile 3, median, and so these pieces of informations you can get by making use of the summary command. Okay, if you don't want these statistics in one go, you can make use of the individual commands for calculating the mean and variances, like here. For calculating mean, the command is mean, variable name. For calculating variance, the command is variance, the variable name. Very simple to remember, mean and var for variance. Then, and we have downloaded the moment package. So you can calculate the standard deviations, SD, for standard deviation. For median, the command is median bracket, the variable name. Okay, friends, you can also calculate quartile by making use of the command which is called quartile command, quantile command, sorry. And if you want first quantile, you write 0.25. If you want median, 0.5. If you want the third quartile, you can type 0.75 as an option. Okay, to calculate the measures of dispersion, you can calculate IQR, you can calculate the range, you can calculate the maximum and minimum. That will give you the range. The difference between the maximum and the minimum will give you the range. You can also calculate what is called the trim mean. If you believe that you have very extreme values, okay, then it is possible for you to trim your data, trim your tails, and then calculate the mean of it. Here we have a command for it, the mean, the variable names, and the option trim. So if you want to trim 5% at the tails, you write 0.05. If you want to trim 1% of the tails, then you write 0.0. So depending upon how many observations you want to trim, you put that particular number. Okay. Then for calculating skewness, so and for calculating skewness and kurtosis, the commands are simple. Skewness, and the variable name. Suppose the variable name is birth rate. And if I want kurtosis of it, and birth rate. Simple commands. And through this, you can calculate the basic statistics. Okay. So let me run the basic statistics for mean for these numbers. And now you can see the mean of the computer, sorry, mean of the birth rate, mean of the death rate, mean of the infant mortality. And you can also calculate the variances by making use of the variance command. And you can also calculate the standard deviations by using the standard deviation command, like here. These are the standard deviations which we have. These are the variances which we have. Okay, so friends, you can easily, comfortably calculate the summary statistics or descriptive statistics in R. Commands are quite simple: mean, var for variance, SD for standard deviation, okay, median, quantile, and skewness, kurtosis. All those commands you can comfortably use. Like here, I can calculate the medians. See, the median of the birth rate and median of the death rate, and this. You can also calculate the quantiles by using these commands. Quantile 2 25, that is Q1, Q2, and Q3. And you can see here 25%, 50%, and 75%. These are the values of quartiles. You can also calculate the interquartile range, and that the range command gives you the value of the maximum and the minimum. But by taking the difference, you can calculate the range, which is 15.1. That's the interquartile range. And let's see, how do we get the other descriptive statistics? You can calculate the trim mean and the skewness and kurtosis of the birth rate. So it's not, I think it's skewed. So I have to first install that moment. That moment library has to be installed. Then I can make use of kurtosis. Then I can use skewness also. That's how we get this. So you have to first install the movements library in order to get the skewness and kurtosis. So you can see this is the trim mean, that's the skewness, which is positive. That means it has a long tail on the right hand side. Kurtosis and lower than 3, so it will be it's a positive 2. That means it is going to be a leptocurtic. So friends, that's how you can calculate the summary or descriptive statistics by making use of R. Okay, so let me summarize how you can get the descriptive statistics. You can get descriptive statistics in Excel by using data analysis, and then select descriptive statistics. And almost all descriptive statistics you will be able to get in it. And if you want it in R, then use mean command, median, all small. You can calculate variance by this command, standard deviation using this command, IQR, interquartile range of the variable. You can also take the range, small, like this. Okay, and in order to calculate skewness and kurtosis, you have to download a library which is moments, and then you can make use of the skewness X and kurtosis X. So friends, I hope you are able to get an idea how you can get the descriptive statistics. Uh, I get a query from Dr. Dalbir Kaur. If the data is not normally distribution, then how do we interpret it? So, madam, the question is not how to interpret it. If data is not normally distributed, you have to do further analysis, and then accordingly you can, apply the interpretation. What I mean by this, let me explain to you. Suppose I go for hypothesis testing and I find that my data is not normally distributed, then I cannot make use of Z test, which is the normal probability distribution test, or T test. I can't use that. I have to go for non-parametric test. Okay, so depending upon what kind of analysis you are doing, you have to have the interpretation accordingly. But descriptive statistics has nothing to do, the interpretation of the descriptive statistics has nothing to do whether your data is normal data or not a normal data. If the skewness is not zero, then at the most you can say the data is not normal. That's it, nothing else. If the kurtosis is say 4, for example, you can say that the data is not normal, but you cannot say anything about that. Okay, so depending upon the value of the parameter which you have estimated, you have to give the interpretation accordingly. Okay, so I hope this question is clear to you, right?
Yes, sir.
Okay. So having discussed about descriptive statistics, let's move to sampling. Samples are the end result of the process which is called sampling, and it is that which we are going to talk about. So if you need sample data, then the sample data will be generated through a process which is called sampling. Okay. Sampling is a procedure to be followed in enumeration of partial information about a population. And the final output of the sampling is your sample. One should follow a sampling procedure such that it reduces or minimizes your errors which you might commit while collecting your sample. Whatever sampling method we use, we divide broadly into two categories: probability sampling methods, that is the sampling method which are based on the concept of probability, and non-probability sampling methods, which are not based on probability. Okay, so let's see what are the methods which are available under the heading of probability sampling methods. In probability sampling method, the selection of elements from a population is random or probabilistic. That is to say, in a probability sample, each element has a non-zero probability of being selected. And no element is having a probability of 1 being selected. The probability should always lie between 0 and 1. So if you select a sample on random basis, then we say you are making use of probability-based sampling method. This could be simple random sampling, systematic sampling, stratified sampling, cluster sampling, and multi-stage sampling. Let's understand them one by one. In case of a simple random sampling, each observation in sample selected randomly in a manner that the chances of selecting any observation are same as those of the others. In simple random sampling, every observation has equal chances of being selected. And since everyone is having equal chances, nobody is getting any kind of a preference, we call such kind of sampling as a simple sampling. Then we have what is called a systematic sampling. In it, observations are selected randomly, but each time when we select an observation, it is the kth observation. However, the initial seed is usually random. So for example, if we have the list of the respondents, so randomly you select the initial number. And suppose I say my initial number is 50. Then we define a rule that every 10th respondent will be my part of sample. So then first will be 15, then 25, then 35, then 45. So if you select samples in this manner, then you're following a scheme which is called systematic sampling scheme. Then we have what is called a stratified random sampling. In it, population is divided into non-overlapping subpopulations called strata. So you have a population. In that population, you will divide your population into different groups, which are called strata. And then items are selected from each strata randomly. So when we talk about stratified sampling, in it the population is divided into non-overlapping subpopulations, which are called strata. And now question is, what is a strata? Strata is a distinguishable subgroup of a population that differs greatly from one another with respect to some criteria of interest, while the observations within this strata are homogeneous. So for example, if we make our sample on the basis of slum area, so I can divide my daily population into different slums like Sangam Vihar or Vajirpur Depot Industrial Area or some other. So you will find that within each subgroup, the persons are homogeneous. By and large, same income level, same standard of living, same background you'll find in the each group. But across the group, you will find there are differences. That's how we define a strata. Within group, homogeneous. Across the groups, heterogeneous. On the other end, we have what is called cluster sampling. Again, non-overlapping population, but defined into clusters. And within the cluster, we select the sample randomly. What is a cluster? Again, distinguishable subgroup which are homogeneous to other subgroups, while observations within each cluster differs greatly from one another. So same groups, but within the group, heterogeneous. So across the groups, they are different, but within the group, they are similar. So that's what we call as clusters. Suppose I think I'm going to study the class behavior of the students in a school.
So what I do, I divide my students into two broad categories. One, higher secondary or 11th plus 12th class students, and 9th and 10th. So 9th, 10th, 11th, 12th, they are different. Okay, right? Uh, sorry, I'm sorry. So if I make group of 11th and 12, 9 and 10, homogeneous within, but different across, that's your strata. Okay, suppose I take up the middle class data in Delhi, and I take places like Rohini, like Sarojini Nagar, and things like that. So you will find this across, all are representing middle class, they are same, but within the each group, you may find a lot of variations. Okay, that is what is called cluster. And multi-stage sampling, suppose I have to do sample research or some study on the national level. So I take India, and then I select states randomly. I select districts. I select city. I select the areas, and every stage I'm doing the random sampling. So if you have this kind of sampling procedure, that is called multi-stage sampling. Then we have what is called non-probability based sampling methods, which are not making use of any randomness, any probability thing. Observations are not selected randomly. And the typical examples of random non-probability sampling is convenience sampling. Researcher is selecting sample on the basis of his or her convenience. We go to mall, pick up people and do the survey. That is what is called a survey, which is, that will be called convenience sampling. Then we have judgment sampling. Suppose we want to study the how environment friendly are solar panels. Okay, you may find that ordinary person may not be able to answer these questions. You have to talk to the experts and those people who have, specialized knowledge about solar people. That's your judgment. And you pick those people who have knowledge in that particular area. If you are doing sampling in that way, you are using what is called a judgment sampling. Then we have what is called snowball sampling. You pick up X, from X you get a reference of Y, from Y you get a reference of Z, and that's how you are collecting your sample. So one person referring to the other, you go to that person, that other person is referring to third person. Like this, if you go on collecting sample, you are using what is called a snowball sample. And then you can have the quota sampling. You can fix the quota of the classes of the respondents and pick the people from that. In that case, you are using what is called quota sampling. Okay, so these are some of the non-probability sampling methods. If you ask me, should you go for probability based methods of sampling or non-probability based? For getting the good quality results, then probability based sampling procedures are much better as compared to non-probability based sampling methods. But seeing your constraints, seeing your special kind of problem, which you are handling, seeing your, the number of respondents, you have to take a call whether you should go for probability based methods or non-probability based method. But try to go for probability based method if it is possible for you as a researcher. Okay, so friends, this we have already discussed: convenience sampling, judgment sampling, snowball sampling, and quota sampling. So that's all, friends, I want to discuss with you in this particular session. And if you have any questions, you are most welcome for it. Trust that you are able to understand whatever we have discussed in this particular session. If you have any question, any doubt, please throw your query and your questions.
Participants are requested to post your queries on your chat box or discussion forum on platform so that we can ask Dr. C.P. Gupta, sir.
Can they put me in direct question, or it has to be routed through you?
Just a second. Just a second, sir.
If there is no query, then we can wind up the session.
I have checked on YouTube. There is no query, sir. Ravindra,
Okay.
sir, you are checking on a discussion forum.
Yes, sir. Yes.
Okay, okay. On YouTube, there is no query, sir.
Okay.
Just a second. So I think we can wind up this session. So
So shall we stop now?
Right. So thank you very much, friends.
thank you.
Please formally thank you.
Thank you so much, sir. Sir, your lecture has been immensely entertaining, and participant is asking the logic behind so informative, explanatory, and interactive. We thank you for accepting our invitation so promptly and sparing time to deliver the lecture. Our participant must be as well equipped with the information on statistics and sampling as Dr. are. Knowledge will handle many of the participants listening methods to get better sense of the information at hand. So thank you so much, sir. Thank you. It's a pleasure.
Hello. Hello.
Thank you. Hello.
Yes, Mr. Ravinder.
Uh,
Thank you so much, sir.
Thank you. Thank you.
Sir, can you make us host someone from our team? A host.
No, I am the host now. Don't worry. So
Okay. Okay.
Yeah.
I'm just
Stop recording
stopping
and
that.
stop live. Okay.
Okay. Thank you so much, sir.
Okay. Thank you.